Hi, my name is Rukayya Ibrahim. I'm an assistant professor of mathematics at Penn State Harrisburg. I was brought up in Kano, Nigeria, and I went to grad school. I got my PhD from Southern Illinois University in Carbondale. And my research interest is in space-time data modeling, and multivariate time series analysis. Now, I want to kind of go back and see some history about space and time. So this is a digitally restored image from the people of Guatemala, and it shows migration pattern and agriculture and territories and dynamics of time and space, and the fact that this exists in the 1500s is so fascinating. Yeah, I love this satellite images, and this is an image, a video from NASA. It's a time lapse video, and it spans from North America to Africa. And in it, we would see how like the clouds are moving and the satellite is moving. Time is constantly changing, space is constantly changing, and for those of us, especially with parents or those of us from the millennium, would agree that like that time is kind of full of fascinating information about the space-time continuum, and then um, I find these NASA time-lapse videos to be so amazing, really. So time series is data collected over time intervals, and these are some illustrations of properties of time series. So we would notice some of these plots have like a pattern. So we call that seasonality, kind of like when we record um, monthly temperatures over years. So there's bound to be highs in the summer and lows in the winter, and then that would be cyclic over all the years. And also sometimes when we measure, like kind of like when we look at the COVID-19 time series data, at the point of when the whole lockdown started, there would be maybe like a dip in the number of positivities and so on, and that would be determine what kind of time series are we dealing with. Spatio-temporal data or space-time data is data collected at with both a spatial or space and a time property. And there are so many different types of space-time data. We have some illustrations of such data. The first one, the top left graph, has like point processes, which are readings collected at certain points or places, kind of like wind gauges at several locations or temperature reader at several locations. And the top right plot is a similar pattern, and the bottom left is kind of like a smooth map, so it's kind of like a heat map that is measuring some phenomenon. It might be altitude or temperature or wind speed and so on. And the bottom right graph is the kind of chloropleth. So it's the space here is counties in a state. So counties, and the color represents how high or low values are, and these are just some examples of the several different kinds of visualizations possible with the space-time data. So the goal, what is the goal? So the main goals are prediction and forecast in time series and space-time data analysis. That is the goal, to make forecasts and predictions. What we have in historical data, what do we know, or what are we sure is going to happen, and how sure are we? And this would help us in building very good models and get to preparing for any uncertainties that come with the dynamic of time. As with any task, the time series analysis or space-time analysis comes with several many challenges, but these are the more forefront. So data are massive. Data is constantly being taken. So that's why we have like the popular fields of big data. So data are becoming consistently massive, and there is pressing need to kind of develop models or do analysis that would help us to accommodate such high dimensional data. I give an example here of the performance measurement system in California that has been taking measurements since 1999 every 30 seconds, and there's so many of them. And this is happening in almost every big city, in every like big country around the world. And the second case is that of high dimensionality. So all data, almost all time series data or time space data, has so many different attributes attached to like one entity. So when we have data that has so many different attributes, how do we characterize each element in that data set with each of these attributes? We need like a way to do that and to efficiently handle the quantity of the data. Another very common problem is the problem of missing data, because machines tend to malfunction. Human error is there, and sometimes there's yeah, so much missing data, and then that's also a big problem. So there's a need for developing models or doing time series analysis with these challenges in mind. So my research is mainly focusing on using tensors to tackle such problems. So tensors are multidimensional arrays, and we can look at a scalar as a zero-dimensional tensor. One-dimensional tensor is a vector, a two-dimensional matrix, which is like the common way we store data. Each entry has a row and column attribute. So tensors allow us to take an element or take an individual or take certain reading and attach so many attributes to it, because in a three-dimensional tensor, three attributes can be connected to an element, and in a four-dimensional tensor, four attributes would be connected to an element. So a four-dimensional tensor would allow us to collectively join or model or analyze data that has both space, which is known to be three-dimensional, and the time, which can be the added fourth-dimensional. So we have like a kind of uniformity and a kind of new way to look at the space time continuum. So next, I want to give examples of such data I've been dealing with. So um, this is the like some financial data from some big companies in the tech world, and it's the companies, the kind of financial value, and then the time series, and it's represented in a form of tensor. So it's instead of rows and columns, we have a third dimension representing the time. Another application is in traffic intelligence system, where most like big cities sometimes have sensors attached to their highways. So these sensors measure traffic flow at regular time intervals, and we use kind of like a matrix valued data, where maybe the rows represent the sensors and the columns represent the times, and then these are being recorded at time periods. This would allow us to like make intelligent decisions about traffic flow or traffic lights and so on. A third example is that in ecology, this example can be applied to temperature or altitude, latitude, and so on. So the space is divided into 7 regions, and the quantity of fish in each study region is detected, and then the data is represented as a tensor, and then we proceed from there. This project would be beneficial to the student in that they would be able to extract or source real life data as it happens, prepare the data, analyze the data, identify key moments in the data, identify time series, structures happening in the data, and be able to use the data for predictions and forecasts. Another important aspect would be the ability of the students or the opportunity of the students to learn how to visualize data and interpret these visualizations using different packages in the softwares.